All right, looking at the homework on page 565, we're looking here at 1 through 3. In number 1, it's set up very much like the sample problem we did in class. You'll notice that a 5 microcoulomb charge, let's color that one red here. A 5 microcoulomb charge is at the origin, and when they say at the origin, they are meaning that it is on an xy axis at point 0, 0. A second charge, negative 3 microcoulombs, let's color that one blue, is on the x-axis at the 0.8 mark. So I'm going to put that here, 0.8 meters. A distance there. And find the electric field at a point on the y-axis, 0.5 meters up the y-axis. So that's going to be 0.5 meters, and I'll put a nice little star here just to kind of differentiate. That's where our test charge is. So just like we did in class where we are using the formula, let me come over here and copy and paste it from this previous page here. Drop it there. Whoops. Twice. Twice is actually fine. Where we take our formula here and they give us the charge for number 1. We're going to do 2 calculations. One, we're going to find the electric field strength of the red charge at this location, and we're going to find the electric field strength of the blue charge at that location. So you're going to take this one and you're going to say the half a meter is there. You're going to take the charge given there and calculate it. And then for this one, you're going to have to use Pythagorean theorem, a squared plus b squared equals c squared. Okay, and you'll have to find the distance doing that. And you put the distance there and you put this charge, the negative 3 microcoulombs. Make sure you put those into the times 10 to the negative 6th. Okay, and then you're done. The book would have you combine them using trigonometry. We're not doing that. We're just going to calculate these 2 answers and be happy with our answers. Moving on to number 2, let me pause the recording and reset my illustration. For number 2, they give us a proton and an electron, and they give us a distance here of 5.3 times 10 to the negative 11th between them. What is the magnitude and direction of electric field set up by the proton at the position of the electron? Oh, wow, I was misreading this in class. I apologize to anyone who I explained this to in class. What is the field of the proton at the position of the electron? So if that's our proton, our test charge goes where the electron is. Now, we know the charge of a proton, that's our 1.6 times 10 to the negative 19th, positive. So that goes here, charge, at the position of the electron, so it's the same distance as the electron. Here's where we're doing our test reading from. Plug that 5.3 times 10 to the negative 11th in there, and you just solve it out and you're done. One calculation. And then for number 3 here, now you got to use the other equation. Hold on one second. Now for number 3 they ask us, an electric field of 2 times 10 to the 4th newtons per coulomb is directed along a positive x-axis. So all that means is you got this electric field that's just kind of going that direction. They give us a magnitude for it. Part A, what is the electric force on an electron in the field? So in the problem, they give us the field strength, and we're going to use for part A an electron for the test charge. So if you plug in the charge of an electron, 1.6 times 10 to the negative 19th, negative mind you, in there, and you have your field strength, then you're just going to solve for electric force. You'd have to multiply both sides by the test charge. In part B, it's the same deal, except for now instead of the electron charge, you'll use the proton charge. So there you go.